All right, well, I hope you enjoyed the musical introduction. This is Brad Sullivan. I am a professor at Community College of Denver. I've been teaching for 30 years or more, and I have the Brad Guitar Man math channel on YouTube. So I almost always start off with a little music to get you in the mood of learning whatever it is I'm teaching you. So, Calculus 1 is the topic, and what we're going to do to start with on this very first section is look at secant lines and tangent lines, both of which have a very, very deep meaning and important meaning in the context of learning calculus. So to begin with, we want to differentiate between these two concepts. A secant line is when you have a function and then you're going through 2 points on the function. So in this diagram, you have this point AF of A, XF of X. You're just simply finding the slope of that line that goes through those 2 points. And you've learned earlier the slope formula. That will be something we'll be working with and then you'll need to review. So the idea is if the 2 points on the secant line get closer and closer, in fact, if they get infinitesimally close, which means just as close as you can possibly get them without them being the same point, then you form a tangent line. So you can think of a tangent line really only touches one point in a real small region around that point. So that's the difference between the two. I like GeoGebra apps a lot. I'm going to open up this right here. There's all kinds of great apps that have been put together on the internet, so I like to use these a lot. So this is kind of showing you what we're talking about. I'm going to take 2 points on this curve. I've got this first point and then this second point right here. And basically a secant line, all that's going to do is connect those 2 points right there, and we're going to find the slope of that secant line. What we mean by delta x and delta y is simply delta x is the distance between this x value on the first point and the x value on the second point right there. So we call that delta x. Delta y is the difference between the y values. So this first y value would be f of c. Second one would be this y value here. So delta y is this change right there. So what you're doing is you're doing the slope. You're really doing a ratio of the change in y over the change in x. You're used to thinking of that as the slope formula. Now, if I do a tangent line, notice this tangent line represented in red only goes through 1 point. And the idea is I can move these 2 points on this secant line. As I move these points, you can see the slope of this line is changing. And what happens is the closer and closer those 2 points get to, well, that secant line, which you see in green, is going to get closer to the actual tangent line. So think of these 2 points as getting as close as you can possibly make them, and then eventually it becomes the tangent line. So I want you to think about a secant line, 2 points, but when you close that in and get those 2 points as close as you possibly can, then it just becomes a tangent line. Okay, so that's kind of a nice application, GeoGebra app, to kind of help you see that then. Okay, so back on the next thing is there's going to be some things that you'll need to review. You need to be really confident from your background that you know how to compute the slope of a line, and you also need to know how to find an equation of a line. And these are two pretty important formulas. We have the slope formula. We use m to represent the slope. It's a ratio of delta y over delta x. More specifically, delta y is just the difference between the y values. Delta x is the difference between the x values. You're kind of used to thinking of this as the rise over the run. That's what delta y over delta x is telling you anyway. Okay, and then the point slope formula is a way that you can find an equation of a line if you know a point and you know the slope. Okay, I think that's supposed to say is a point on the line, is a point on the line. All right, so these are the things you want to definitely review. One thing that I post a lot of times in my classes is some review videos. Khan Academy is a great place to go to anytime you need to review any algebra. I think I posted this. What I like about Khan Academy is it's pretty interactive. They'll have a video talking about slope, talking about concepts. Then you'll have the chance to go through and do some practice. This is optional to a Calc 1 student, but I want you to know that those things are posted in case you come across something that you think that you may need to review. Okay? All right, slope is a big deal in calculus. As we study the first few weeks, you're going to see that we're going to be talking a lot about slope. Okay, another basic thing you want to remember from your background is positive slopes slope upwards, negative slopes go downward, zero slope is horizontal, and an undefined slope is when your line is vertical. Okay, so we're going to go ahead and kind of begin to put together the basic concepts that you want to learn to start with. So I'm going to go through this example 1. So I've drawn a function on here, a graph of a function. We're going to draw a secant line through x equals -4 and x equals -1. So let's go to x equals -4, which is right here, and I'll put a dot on the function. And then let's go to x equals -1, which is right here, and then I'll go to the function like that. So all a secant line is it's just simply the line that connects those 2 points. So that would be your secant line, and that first one would have a positive slope because it's sloping upwards. Okay. Now I'll take a different color and we'll go with this one. I'll use green. So we're going to go to x equals 0. So x is 0 there. We're going to put that point on the function, and then we're going to look at x equals 2. And we're going to go like that. So the secant line would just mean that we are going to join those two, and then that one would have a negative slope since it's sloping down. Okay, so that's what we mean by a secant line then. Okay, now what we're going to do is do a tangent line. And on this one, we have just a given function, a very similar function, f of x. And what we're going to do is draw a tangent line at x equals -1. So we're going to go to where x is -1 and put a dot on there like that. Now I'm going to zoom on this a little bit so you can see what I'm doing. So really the idea is if you think of a point just barely, I mean, as close as possible. When I draw a tangent line, I usually like to just put a couple of dots that are as close to that point as I can, and then think of what it would look like if I connected those 2 points. So that would be what that tangent line is, and it only touches that one point. So it's going to only go through that one point in a small neighborhood. It might hit the point of this function later on, but in that small neighborhood, it's only going to touch one time. And then this one right here, you would have a positive slope, again, because it's sloping upwards. Okay, so that one would have a positive slope. Okay, the next one, we're going to go to x equals -4. So -2, -3, here's x equals -4. We'll put a dot there. And again, I just think of it the same way. A dot just next to it. And then think of what it would look like if you connected those dots. So that will be a good way to draw a tangent line then. Okay, and then that one's got a negative slope because it's sloping downward. Okay, and then finally, the last illustration is C. We're going to draw a tangent line at x equals 0. Okay, so what's going to happen here? We're at this point. Again, if we think of 2 points as close as possible, and we think about connecting those, then we're going to get a horizontal line. And anytime you have a horizontal line, the slope is equal to 0. So you have a 0 slope, okay? So that's what we mean by tangent lines, is we touch the graph in one point only in a small region around the graph, okay? And to draw one, I usually just tell students, just think of points very close as possible to that given point, and then connect those dots. Okay, so that'll give you a good understanding, hopefully, of the difference between a secant line and a tangent line. So I'm going to do one example, then I'm going to give you a little time to try to reproduce what I'm just doing. For this problem and the kind of things that you'll see in your assignment, it's really helpful to use a graphing calculator. So what we're going to do is we're going to take this given function and we're going to just graph that on the calculator to begin with. Okay, so I'm going to go to y equals, I'm using a TI 84 plus, and I will do square root of x plus 2. You want to make sure you type that in correctly like that. And then I'm just going to do a standard window. What I always do on a standard window, instead of setting the window up, I just go zoom, option 6, zoom standard. That just means that the window is going to automatically set from -10 to 10. Okay, so if I go to my window button now, you'll see it in this standard window like that. Okay, all right. So what I'm going to do is we're going to do some calculations on this, and you want to use your calculator to do this pretty quickly. This is the x value, and I'm going to use this trace button, okay? If you're not familiar with this, you definitely want to get familiar with this. So when you type trace, then you should just type in the x value, and then we're going to record what that function value is. So what we get really is f of 1.1 is equal to, and we got all these decimals, 3.048. God, I can't see that very good. Whoops. So let me do that one more time. We're going to trace at 1.1. And let's see, I'm seeing 3.0488. I'm going to write out whatever comes out on the calculator. Okay. And then when I go to this next one, again, I can trace again 1.01. And I'm going to record what I get here. It'll be a little different. So we have f of 1.01. That looks like it's 3.0049876. Okay. And then usually on a calculator, you only have to type the trace once. I'm now going to trace at 1.001 and record what I get. Okay. So I'm doing f of 1.001. That's going to be equal to 3.0004999. And then lastly, I'll do the 1.00001, and I'll get a little bit different value. So this time I get 3.00005. That's what f of 1.0001 is equal to. Okay. All right, so you want to get all those things just from the graphing calculator, and we'll need to use our calculator to do these. So what we're going to do is we're going to do a slope of a secant line, but we're going to use this original point right here. So if you do f of 1, you just plug the 1 in, you would get square root of 1 plus 2. That's 1 plus 2, so that's equal to 3. So we're going to use the point 1,3 in the slope here. Okay, so what we're going to do is when we do the slope of the secant, we're just going to use the formula. You can use change in y over change of x. You're doing y2 minus y1 over x2 minus x1, and we'll need to use our calculator to do that. So the y values are going to be 3 and this number right there. Okay, so to begin with, we're just going to do 3.0488088 minus 3. That'll be the rise, the change in y. then the x's are going to be the 1.1 and the 1. And you're using this slope form. You want to do this in the same order. So we will do the y value 1, the x value 1.1 minus 1. Okay, like that. All right, so I'm just kind of trying to highlight this to show you what I'm doing is I'm finding the slope between these 2 points. Okay, then I can do this on the calculator, or you can do this in your head. That's just going to be 0.0488088 over 0.1. Then we're going to go ahead and go to the calculator if you need to. Now, when you divide by 0.1, it just moves the decimal over. So when you're doing this in your homework, you can save a lot of time if you know basic things. So let me show you what I mean by that. So if you go 0.0488088 and divide that by 0.1, well, the decimal moves over. So you get 0.488088. Okay, then that's going to be the result. That is actually the slope of the secant line that goes through these 2 points. And then what we're going to do is we're just going to repeat this. Okay, same thing over and over again. So slope of the secant line. The next one, we're going to take the y value, 3.0049876, minus the y value 3. Then we'll do the x's the same way. The x values are going to be 1.01 this time, minus 1. So that gives 0.0049876, and then divide by 0.01, like that. And what this is going to do, it's going to move the decimal to the right 2 places on this. So once you kind of catch on to this, you can just do this in your head. So 0.0049876 moves this over 2 decimal places, so you get, oops, I didn't do the right thing. So let me do that again, 0.0049876, and we want to divide by 0.01. And like I said, this will just move the decimal over 2 places to the right. So that's 0.49876. So what you're seeing is these slopes are changing. And once we get all these crunched out, we'll talk about what's going on in the problem. All right, so we're going to crunch out the next 2 then. And this goes like this. Same thing here, slope of the secant line, take the y value, 3.0004999. Change in x would be 1.001 minus 1. So that's 0.004999 over 0.001. That's going to move the decimal, and I think I missed that a little bit. That's an extra 0. So if you did that on the calculator, you would get 0.4999 like that. And look at what's happening to these numbers. They're getting closer to something. That's what we're going to kind of talk about here as we go through this. Okay, let's do the last one. And again, same idea, slope of the secant, 3.00005 minus 3. And then the change in x would be 1.0001 minus 1. So that's 0.00005 over 0.0001. That's going to have the effect of moving the decimal over 4 places, so you get 0.5. Okay, and what I want you to see on this is these numbers, they're getting closer to 0.5. Okay, and what's happening on this is getting close to 1, and then the slope gets close to 0.5. Okay, if we carried that out more decimal places, it probably wouldn't be exactly 0.5. It's just getting closer to it. So that's what I'm wanting you to see. The closer we get to 1, the closer the slope gets to a value. All right, so you want to fill out a table to help you see and learn that concept. Okay, now we're going to use the results to estimate the slope of the tangent line. Well, the slope of the tangent line is going to be about 0.5. Okay, because remember, we're using the closest points that we can. Okay, and the points that are the closest are 1 and it's these 2 points. We have 1, 3, and we had 1.0001 and 3.00005. Okay, so the closer these x values get to each other, the closer the slope gets to the slope of the tangent line. Okay, all right, now what we're going to do now is we're going to use the point slope formula, y minus y1 equals m times x minus x1. The slope of that tangent line, we're going to use 0.5, and then the point is 1, 3. So we're going to use that information and plug that in. So it goes like this. Plug in the y value, 3. Plug in the slope, 0.5. Plug in the x value, 1, like that. So you plug the point in. You always plug the point in to x1, y1. So that's where your 1, 3 plugs in. And then you plug your slope in for m. Okay, and then what we'll do is just work this out. Y minus 3 equals 0.5x minus 0.5. You can add 3 to both sides, so you'll get y equals 0.5x minus 0.5 plus 3. So you end up getting y, whoops, I think I missed my equal sign. Okay, so I end up getting y equals 0.5x, and then that would be plus 2.5. Or you could write it as y equals 1/2 x plus 5 over 2. Okay, so that would be the answer that we get on the equation of the tangent line. Okay, and that's what we're ultimately trying to do. A little later in the calculus course, you'll learn an easier way to get that 0.5 by using what you call the derivative of a function. So we'll be getting to that pretty soon. Okay, last thing I want to do is go through and use our calculator to graph. So we're going to go ahead and graph the function, and we're also going to graph the tangent line. Okay, so I'm going to clear off. I'm going to go to y equals, and we'll put in square root of x plus 2. Okay, like that. And then we'll also do the tangent line. So I'm going to put in, I'm going to put the fraction in. If you do a fraction, be sure that you enclose it in parentheses, because if you don't, it's not going to graph that correctly. It needs to change that 1/2 to 0.5. The 5/2 you could leave out of parentheses and it'll still work okay. And then we're going to set our window up like this graph here. So I'm going to go window -6 to 6 on the x-axis. And then the y-axis, we're going to go -6 to 6. Okay, if you're not real familiar with a window, it's one of the things that you'll be doing a lot in a calculus class is using your graphing calculator. So we get everything set up. That's how your window will go. And now if you type graph, you're going to have the function and the tangent line. So really what I'm going to do is we're just going to take this and we're going to sketch these two things. All right, so first of all, I'm going to go ahead and sketch the function. You can go to a table of values if you want to, and the blue graph is the square root function. So I'm just going to get a couple of points, like here's a 0.02, here's a 0.13, and I'm going to label that one as 1,3. And then here's another point, there's a 0.44, and then we'll just kind of sketch in that curve like that. So that is the function f of x equals square root of x plus 2. Okay, now we can do the slope of the tangent line the same way. I mean, you can just plot points, but I want to remind you that if you have y equals 1/2 x, and then I'm going to use 2.5, well, this is the y-intercept, and then the 1/2 is the slope. Okay, so I'm going to graph this in red. So the y-intercept, I'm going to go to 2.5. Then I'm just going to go up 1, right 2 for the slope. So up 1, right 2 would put you there. And then if I connect those dots, then I get that tangent line. And the thing is, you can tell this looks right because you can tell that that tangent line connects that graph at that point right there. Okay, so this will give you a good way to tell if you're finding the slope correct and you're finding the equation correct. If these things don't connect, then you're incorrect. So for instance, if you had, say for instance, you had, this is your answer, you had 1/2 x plus 1. Well, they don't connect. They don't connect at that point. Okay, so you would know that that's not correct. Okay, so that's one of the type of problems that we're going to be doing. I'm going to go ahead at any time during these videos. You can post. You can pause if you anytime you want to. I'm going to go back and put this in here, and then I'm going to have you do a problem. I always on my problems. I like, or on my videos, I like you all to do a problem or two just for a little practice. Okay, so I'm going to go to the next page, and you're going to repeat what I just did with a different function. And go ahead and pause your video, use your graphing calculator. When you're done and you have an answer, just resume, and then I'll have the answer posted for you, okay? Okay, so I'm going to post the solutions to this and see how you did. Okay, so really, so much of this is just using your calculator and understanding how to do a slope. So let's go ahead and get this up here, and we'll see how you did here. So on your table, ultimately you were looking for that you got these slopes. So if you're using the points 1, -2, and then you're using 1.1, then you get this slope, -0.90909. 1.01, so you're getting closer to 1. The slope changes a little bit, it's -99.01. And then if you use 1.001, you get -0.999. Finally, when you do 1.0001, you get -1. So what I want you to see is we're basically getting closer and closer to 1, okay? And as we get closer, we're getting close to making a tangent line. Still, technically, it's a secant line when you use 1 and 1.0001 as your x values, but the slope gets closer to the exact value of the tangent line. And in this case, the slope of the tangent line is going to be -1. So that's how you know to use this as the estimation of the tangent line. Okay, then when you find the equation of the tangent line, well, we use our slope of -1, we use the point 1, -2, plugging into the point slope formula, you will get y equals -x minus 1. Okay, so you can verify the details on that and see if you got that. And then your graph would kind of look like this. The function is coming out in blue. You have the point 1, -2, and then if you graph the tangent line y equals -x minus 1, you're going to see that that connects exactly the way that it needs to connect. So you can tell you're right because that tangent line is only touching that point 1, -2. One thing I did notice on this that, you may have come across, I think this happens to students sometimes, is you'll get some scientific notation in here. So I wanted to show you kind of what happens on this. So like when I did this 1 point, let me zoom on this just a little bit so I can see this a little bit better. So if you do this 1.01, we'd be doing the -2.009901, and we're subtracting -2, which means we're adding 2. So you get this, and that didn't come out in scientific notation this time. But if I divide that by 0.01, it may come out in scientific notation. That didn't that time. I think maybe it was the next one that came out that way. So if I did -2.0001 plus 2, there we go. It's in scientific notation, so I just wanted to show you that what this means is this means -1.0 times 10 to the -4. And all it really means is this thing, the decimal gets moved to the left 4 places. So you get 0.0001 is what that turns out to be then. Okay. And after you've put that together, then that's how that goes together. All right. And then you can go ahead and you can just divide that by the 0.001, and then you get, well, I must not have done something right on that. Yeah, okay, I'm all right. Let me show you one little thing here. Yeah, what I did is I put the wrong thing in. I was wanting to show this to you. So if we do this calculation right here, negative 2.000999 plus 2, then that comes out in scientific notation. All right, now you could still, divide that by 0.01, but I just wanted to remind you that if this comes out, because sometimes students don't have a background to show that, I think sometimes it just means you're moving the decimal to the left 4 units, so you get this, right? So that's why I used this number right here, and then I can take that and just divide by the point, let's see, that was the 0.001, and then you get your value like that. So scientific notation will come out on your calculator some. Don't let that bother you. Okay, so that's the end of this video. There will be another video posted for the second part of this when we talk about average velocity and instantaneous velocity. Okay, hope that helps to get everybody on track with this first part of this section. All right, good luck.